Hi, welcome to What Now? What now? I'll tell you what now. What now is pH indicator juice. It doesn't sound fun? It is fun. Watch this. This is made with a red cabbage. A very pretty magical fluid. Potions. Look at the color. It's a delightful purple. I can change it. Whoa. Pink. Just by adding lime juice. So what we're going to talk about today is pH. It sounds kind of complicated. pH is a scale with which we look at things. Are they more acidic or are they basic? So what does that even mean, pH? Well, you've heard of acids before. You know that lemons and vinegar and stomach acid are things called acids, right? They actually are solutions that have extra hydrogen ions. They're giving off extra hydrogen ions, right? On the opposite side of this pH scale are the alkalines or the basics. And those are solutions that kind of want to pull in those hydrogen ions. Those are things like soaps and baking soda. So there's this pH scale, and that's what we're going to be talking about today. And the thing is, when you look at a solution, you can't tell whether it's acidic or basic, oftentimes just by looking at the solution. And some of these things might be toxic, so you don't want to touch them. So how can you tell whether it's an acid or basic? Why do we even need to know? Well, we need to know because that exchange of electrons can tell how a substance can react in a chemical reaction. So what we're going to do is we're going to make a pH indicator solution, and we're going to use this red cabbage to do it. This red cabbage has a chemical in it that makes it purple, and it's called anthocyanin. It's a pigment. And anthocyanin is this cool pigment that when it interacts with hydrogen atoms, if there's more hydrogen ions, it changes the wavelength of the light that hits it, so we get a different color. When something is basic and there are fewer hydrogen ions, again, it changes the pigment of this solution and shows us a different color. So it's the solution that can tell us where something is on the scale of pH, and that's what we're going to do. So here's what you need to make a pH indicator solution and do some testing with a red cabbage. You need a red cabbage. That probably doesn't surprise you. You need a blender. You need some water. You need a colander or a sieve. You want to get the cabbage chunks out of it. And then you need a bunch of different glasses. Now I have a bunch of solutions over here that I want to test, which you want to gather too. I've got vinegar, I've got pine sol, I've got ginger ale, I've got lime juice, baking soda, bleach, and dishwashing soap. And for each one of these things I'm testing, I have a clear glass. So I have those in front of me, plus I have one extra special one, and this is the control, where I'm not going to add anything to it because I want you to see the difference between a solution that doesn't have anything added into it and all the other ones that we make. So first things first, you peel off about 5 or 6 leaves off of your red cabbage. Peel them off. You can also chop it off with a knife. Make sure you have a grown-up with you. You want to have a grown-up with you during this whole experiment too, because you're dealing with chemicals. So you peel off your red cabbage leaves. Aren't they pretty? And this actually looks pretty in a salad too. So, it's a handful of red cabbage leaves. I'm going to tear them up a little bit, and then I'm going to put them in my blender. You need a blender. Then you pour in some water. You pour in about half. I think that's probably about good. Almost half. You're going to put the lid on, and you're going to whip it up. I think that looks good. So that looks beautiful. Little frothy blender drink of anthocyanin. Thank you, red cabbage. Now I'm going to take this and I'm going to pour it through a filter into a jug because I don't want the cabbage bits. Ooh, that's all solid bits. That's fun. You know that? That's all cabbage. I got my jug. Isn't that beautiful? Look at that color, it's gorgeous. So what I'm gonna do is I'm gonna pour it into these glasses, my pH indicator juice. I'm gonna pour it in there so you can see that it's purple. And then I'm gonna pour it in every single one so we can see what we got going on. Now, we're gonna see what happens. Now, water is smack dab in the middle of this pH scale, right? It's not acidic and it's not basic. It's right in the middle. So we're gonna use this as our control because it's just the cabbage with water in it. So that's gonna be our control color. Now, what happens when we take something like vinegar and we pour it in? Well, the vinegar itself is acidic. So let's see what happens when we pour it into the purple. Can you see the color, the purple color? And then we pour it in, and whoa, look at that. So it turns kind of pink red. So we know now that when you add an acid, it turns pink. Let's see what happens when we add lime juice, right? I'm guessing, because I think that limes and lemons are acidic, that if I add lime juice to this, that it's gonna turn it kind of pinky like this. And it does. That's pretty cool. What about this ginger ale? You see? Let's just see what happens. Purple, I don't know. It's got a little bit of a pink to it, but it's purple mostly. That's interesting. So that's a different color. So what happens if we put soap in? Let's put soap in this one. That's kind of hard to tell. Let's stir it up a little bit. I think that got blue. Oh, it did. You see that? Pretty dark blue. It's almost black, but it's blue. In fact, it's hard to see, so let's pour in just a little water into that so we can see the color better. You see that? Blue. Blue purple, huh? Let's see what happens when we put a little baking soda in. That is definitely blue. Wow, can you see the foam on top? You see that? Now, let's see what happens when we add pine salt. This is a bathroom cleaner. See it? I'm gonna put this into the last one. I don't know what color this is gonna turn it. Ooh. Well, that's interesting. It kind of turned it pink. I wasn't expecting pink. So I guess this is more acid than I thought. I would have thought this was more basic. Add a little water to that and see. Huh. So you can see the differences in color here. This is the original, right? There's your pH purple. So next to the vinegar turns it acidic. The lime juice turns it acidic. What was this? Oh, this was the ginger ale. That one's pretty close to that. This is the, what's this one? This was soap, and that's bluey. Baking soda, very blue. And then pine salt, which was a surprise to me, turned it pink. I'm gonna do one more, and I'm gonna use our control. But I kinda wanna see what happens when you pour bleach in. So, well, before I do the bleach thing, I wanna do a couple of things. So like, we know that the vinegar one is acidic and it's got pink in it. We also know that the baking soda one is basic. So what happens if I put baking soda into this pink acidic one? What do you think is gonna happen? We're gonna get a color change? Let's see. So I'm putting baking soda in. It's gonna fizzle. Whoa, it's gonna fizz! Ha, it's a pretty fizz. Changing color too, that's definitely going from pink back to purple, isn't it? And the reason it reacted that way is because when you add an acid and a base, you get a chemical reaction. That's pretty cool. If you look at the spilling liquid, you can see it's a lot more purple. And the same thing will happen if we go over here and we have the baking soda in this one, which had turned it blue, kind of a bluey green. If I add vinegar to it, what do you think is going to happen? So I'm going to pour a little bit of vinegar in. I'm not going to get a fizz, but also a color change. So that's going from that deep blue back to purple. So again, it's the pH in the cabbage. It's the pH indicator in the cabbage that is reacting to whether or not there are more hydrogen ions or less hydrogen ions. If you have more hydrogen ions, it's going to turn pink. If you have less hydrogen ions, it's going to turn bluey green, I think. All right, now this last one that I want to show you, I'm just curious because I had this bleach that was in the laundry room and I wonder what's going to happen if I pour bleach into my pH indicator. Let's see. Whoa, that is cool. So, boy, that turned it kind of yellow at first and then a brown, kind of reddish brown. And then let's give it a stir. Gosh, that's cool. And it looks like it wants to turn it clear. Look at that. So this is another advertisement of never drink the liquids in your lab because if that turned clear, it might look like water, but it is not water, is it? Look at that. That's pretty cool. Make yourself a pH indicator solution with red cabbage and water, and then collect some solutions of things that are around your house, under the kitchen sink, maybe in the refrigerator, maybe in the cupboard, and make some solutions and see what color they turn. See if you can make a pH scale and you can put these substances on that pH scale with water in the middle and all things acid and pink on one side and all things basic and blue on the other. I'm not sure where this goes because it's kind of turning clear here, but my guess is that it's going way, way, way over to the base section because I'm pretty sure that chlorine is looking for hydrogen ions and it is on the base side. Blah, that stinks. See you next time. Have fun pH indicating.